front of me, Arun sir in front of me, and many other professors. Most of them taught me. Some of them saw me working as a research scholar, followed by a resource person for teaching students and all. So I'm really thankful to Principal Sir, the committee, and my special thanks to Dr. Tripti Gangwar for making this event happen, which is one of the most important events in my life that I will always remember. So, and good morning to everyone. And let me start my topic. Let me share my screen. I believe, are you able to see my screen?
Yes. Yes.
Okay. So as ma'am has mentioned, the topic of the talk today, the application of machine learning in environmental management. And since AN College has been my part of my life, so I have extended my topic furthermore, and I have structured my topic into 4 different segments. The first segment will briefly discuss about the machine learning, like what it is. And then we will talk about one of my published work as a case study with machine learning algorithms to address one of the environmental problems, which is groundwater contamination, and people's awareness about it. After that, then I'll briefly also talk about career opportunities in the area of artificial intelligence and machine learning. People from definitely it's a perception that students or professionals from computer science background could only go into artificial intelligence and machine learning career. But there are other opportunities. And at the end, then I will also talk briefly about like how I can contribute to this academic family through collaboration. So I'll briefly just talk about machine learning, and I have created like a very layman language explanation of machine learning. Most of you may have that understanding, but briefly I would say machine learning is a computation technique. In this technique, we train a system, a machine, which learns patterns from historical data that we provide to the machine. And after learning the inherent patterns from that historical data, the machine automatically applies that learning and predict desired outcome on unseen data. So we collected the data, and some of the data we provided to machine, and using some of the algorithms, we trained the machine, and the machine learned the inherent pattern in the data and then applies to a new data. Broad I think there is since this topic is not too much detail about like artificial intelligence and machine learning, so I will just briefly talk about like different important branches. So you can see machine learning has like 3 major branches here. You can see supervised learning, then you have unsupervised learning, and then you have reinforcement learning. So if we take this presentation as an example, so the data will be generated once we are done with the presentation. But we are not supervising the data. So we don't have any structure in information, a structure kind of a format where we are collecting a data. And there is no target for this data. For example, if we would have like a follow-up survey, and that would say who liked the presentation, who did not, then we are kind of like supervising the entire data collection process. So based on that, we categorize into 2 different forms, like supervised learning, where we have an outcome, whether someone liked the presentation or not, and unsupervised learning is just the data that we're collecting. And most of for the reinforcement learning, so it's basically it learns from its previous steps. Each step it learns, and then again kind of like reduces the noise and all. And then this technique is mainly applied in robotics and all, in robotics, self-driving car and all. So we know like this didn't come like overnight. So it has a long history, and it started nearly like 1950s with the concept of artificial intelligence, and with time it grew, and uh, machine learning kind of like became one of the most important computational tools for scientists, researchers, and engineers. And after 1980s, it keeps going. Now we are in the era of deep learning, where we talk about, and then we already hit where we started using quantum mathematics and quantum physics, how we can integrate like machine learning and use quantum physics and mathematics. The topic why we are talking about like machine learning has been applied to various domains. You can name it like in business, in information technology, in insurance, in life sciences, health sciences. But the application of artificial intelligence and machine learning in environmental management and sustainability has recently emerged. So many scientists, they are working on it, but it was not very popular, you can say, or scientists were not very much using it. So that was the biggest motivation for me, because I have spent nearly, I would say, 14 years in environmental science world. So let's go into the case study that I have selected. And as I mentioned, that this is one of my published work that I'm using applied machine learning. The problem statement here we are talking about is about arsenic contamination. And we have Dr. Ghosh sir here, Nupur Bose ma'am, and we know like AN College has been a hub of arsenic research. The arsenic research started in Bihar, and then we did a lot of work. Currently, when at that time, I remember around like 70 countries were arsenic contaminated. Now it's 109 countries contaminated with arsenic, like the groundwater in those countries are contaminated with arsenic. And if you see the population, potential population exposed to arsenic, nearly 300 million population are potentially exposed to arsenic. And you can see Asia is the hardest hit. So we most of us know about arsenic, and maybe I don't want to go into all the health impacts, but one thing I would say, like you just name the diseases, and then you will be able to find relevant literature that how arsenic could cause different diseases, including various cancers and impact on IQ of children and other communities. So what's the problem? Why we are talking about arsenic now? Because arsenic research has been for like a deep, I would say like a century. It's more than 100 years people have been studying and investigating about arsenic and all, and there were like $1 billion invested. Is somebody's asking questions? Shilpi Kumari?
We'll have an interactive session after the lecture. You can ask the questions then.
Okay, okay, thank you. So, $1 billion have been spent on arsenic mitigation. But where is the challenge? What's the problem? So, majorly two challenges were identified, one technical, and the second one was socioeconomic aspect. So basically, most of the areas you'll find like there are good arsenic mitigation technologies, people are using it. But the biggest problem is the lack of sustainable arsenic mitigation. When I realized after reviewing several literatures and all, that what I found that the lack of research on socioeconomic and behavioral aspects of arsenic contamination and mitigation was one of the prominent, you can say, the gaps. And secondly, at that time, when I started investigating back in 2010, the lack of socioeconomic model of sustainable arsenic mitigation, there was no such model at that point of time. And I also didn't find any published literature when I was reviewing the application of any information technology tools and artificial intelligence techniques. So I was like reading and then started working. I collected my data in 2013 and then I was going through it. And you will see like since 2001, many scientists, they started raising concerns that arsenic awareness is a big problem. If people are aware, they are more inclined to practice good, like you can say prevention measures and all. But there was not like dedicated work on arsenic awareness. So I started working on it, and as I mentioned, I collected data in 2013, and then my first outcome, my first results, you can say, like how the arsenic affected perceived risk. So, you know, like risk perception is very, very important. Unless and until we perceive a risk, for example, we have the biggest example we are talking at the beginning, a ma'am said like only 5% people, they wear one mask. Why? Because they don't perceive the risk. So that risk perception plays a vital role in decision making of adopting any kind of like preventive measures or any policy. And that work was featured in Nature Asia into 2014. And after that, then I developed the first ever socioeconomic model of sustainable arsenic mitigation. And that work was published in Current Science. And this work was totally based on logistic regression. And this was a pure statistical model. Now, as I mentioned, there was no dedicated work on arsenic awareness, and there was no such model exist that will say, hey, these are the important factors that could lead to people's awareness. Yeah, there are some other studies that definitely says that maybe gender and others. So if you see the recent one in 2017, Mondal et al., they published and they found that literacy has a positive association with arsenic awareness. So by that time, it was very clear and prominent that arsenic awareness plays a key role in sustainable arsenic mitigation. Now the study area where I wanted to work, as you know, like I'm from Bihar, and as a scientist, as a human being, it's my personal belief that I have some responsibility towards my community, the place I belong. So even in my first PhD, my project area was Bihar in Maner, and second PhD, I still chose the same area. And the reason behind it, like after all kind of like study and research, Maner block was found to be one of the most arsenic contaminated areas of Bihar. Now, the data collection part is very, very challenging because first of all, it's resource extensive. Then while pursuing my PhD, there were like several things, like you have to have approval from the IRB, then you have to first, since you are going to capture data in Hindi, then you have to translate your questionnaire into Hindi, and at least like people with grade 6 level of students can understand that Hindi, that kind of thing. And there was external expert who can understand English and Hindi both. And then they will say, hey, your questionnaire is good to go. Anyway, those things were done. Then I randomly selected 340 households, and the households were stratified based on their caste. Because one of my hypotheses in my thesis was caste has a kind of a caste is associated with people's awareness and decision making, other things you'll see in coming slides. Now it comes to machine learning models. So there are tons of machine learning models. It depends which model, which algorithm to pick. And in order to select relevant machine learning models, we need to understand like what kind of problem we are trying to solve, and whether the algorithm has that kind of a historical record that will match to my data or not. So after reviewing multiple literature, I found like logistic regression has been widely used by many scientists and researchers. So I use that one. Then support vector machine is one of the very strong machine learning algorithm which has been used by several scientists, and this is considered, it can also capture linear versus non-linear relationship between the outcomes and the predictors. Similarly, random forest is another very strong and widely used algorithm, and so on. Now, I will focus a little more on the framework side, and this is for all the students. So you got the survey done. You have the survey, and you capture all the features that you wanted. And here I just wanted to highlight here, if anybody, anyways, I'm going to share my publication or any information, any material you see here. If you want it, definitely I'll share later. So you capture the data, and then the data I stored in a CSV file. And for the model development, I used one of the most widely used statistical tool, or you can say data mining tools, called RStudio. These days, Python is very, you can say, people use Python because Python has other advantages than RStudio. Anyways, in RStudio, the first and the most important step is data pre-processing. So you gather the data. Now you have to make sure whether the data is a quality data or not, and whether there is a missing information, whether there is an outlier, or all kinds of, like, you have to see whether there is a redundancy and all. So you need to do data pre-processing. So for data pre-processing, since my data was very clean, I didn't have any problem, but still I had to do some transformation and standardization. And after transformation and standardization, one of the most important steps in machine learning processes is feature engineering and feature selection. So feature engineering, basically you already have variables like predictors, and you are creating another one, a new variable out of it. So wherever that was needed, I did it. And then you see the feature selection. So say you collected like 28 to 30 variables while pursuing your survey. Not necessarily all the predictors or the variables have a very strong association with the outcomes. So that's why feature selection is very, very important. And in this case, most of the variables except age were categorical in nature. When you deal with categorical data, it's very, very difficult, first, to identify important predictors, second, to create a very good, accurate model. So I applied contingency analysis and chi-square test to filter down to select important features so that I can develop the model. Now, before doing that, then I also perform like a cross-tab analysis, and using Excel spreadsheet, I created all the charts. Some of the charts you will see here in this presentation. Now, once feature selection is done, then, as I mentioned at the beginning for machine learning, that we need to train the machine. And in order to train the machine, we need to provide data from the population. So whatever data I have collected from 340 households comprising of like 2,500 individuals, I split the data into 75% to train all the models, and I kept 25% of the data to validate it. Now the next step is when I started training, then each algorithm has different, I mean, they treat data differently. It's not like the similar way they handle. One algorithm may have a different way of dealing with the data, and the other algorithm may kind of like respond in a different way. So to make all the algorithms trained in a similar fashion, two steps are very, very important. One is cross-validation, and the second one is resampling. So I started developing the model. The model is being developed and applying the cross-validation and resampling technique. Cross-validation is basically the training data set is split into 10 subsets, and there will be one subset of the data for testing within the training data. And then you run 3 times. You can increase 3, 5, and whatever you think is the best one. I use 3. So it runs 3 times so that it captures all the information and it reduces any over training. And then it provides a similar kind of training fashion across model. Then only you will be able to compare all the models because it has a similar type of like training. Now for the model validation, there are different performance metrics. Since we are dealing with, we are not predicting a number. For example, when I say predicting, so prediction is basically when we are predicting a number, someone's salary. It's a number. But here what we're doing, we're classifying. So whether a person is aware or not. So we have 2 different categories, yes and no. So we are classifying. So that's why we call it like classification. So all the algorithms were classification algorithms. And for validating any classification model, then you have different performance metrics. You have accuracy, you have precision, recall, and all those things. The most important here that I will talk about later is kappa statistics. One is accuracy, that tells about how accurate the model is, and kappa statistics tells you the robustness of the model. Now, once we trained the model, validated it, we found, okay, these are the models which are good, accurate as well as robust, then the model is done. What we need to take away from this slide is basically the pre-processing step and the feature selection, feature engineering, and cross-validation are critical whenever we develop any machine learning model. As I mentioned at the beginning, feature selection is very, very important. I started with, say, 28 features. But after doing the contingency analysis, chi-square test, I found like 14 predictors were statistically significant here. And that becomes like the candidates for model development. And usually when you collect socioeconomic data, environmental data, behavioral data, there is more likely that you will have multicollinearity effect. But I also perform a VIF analysis, variance inflation factor analysis, where I found like there was no multicollinearity effect because you'll see all the data is below 7 or 5. And 5 is very strict. Usually people go with 7. So out of 28 features, I found 14 features, potential candidate for a model development. Now, we are talking about arsenic awareness. So arsenic awareness, how the arsenic awareness was captured. There are different ways. What I did is basically I had 10 questions and then I asked the questions and then I had answer. So once I captured it, then all the 10 questions were pertaining to arsenic. So basically capturing arsenic awareness related information through different questions. Now, in order to develop a model, what I did, using all the 10 questions, I transformed that into arsenic awareness index, and I made it into 2 categories. So basically, if there was no awareness, then people were like, people belong to the category where there is no awareness, and rest of them, they belong to arsenic awareness. So I have created and I have a detailed methodology in my paper. But finally, for arsenic awareness, we became like a binary, arsenic aware, arsenic not aware. And you can see like 64% of the population were arsenic aware. Now the model is done. We did this descriptive analysis. We did contingency analysis, odds ratio, and all the, cross-step analysis and all. Now let's pick one of the graphs and let me interpret like what was the outcome. And then we will go to the outcome from machine learning models. So as I mentioned at the very beginning that my population was stratified based on caste. So if you see here, we're talking about results here. If you see here, caste versus arsenic awareness. So out of 340 households, a majority were backward, 43%, followed by forward caste, and then a scheduled caste. Now you see the arsenic awareness was significantly different across the caste. If you dissect it, each caste, you see within forward caste, 86% respondents were arsenic aware. And in backward caste, 56% respondents were arsenic awareness. You can see in scheduled caste, there was like less arsenic awareness. Sorry. Similarly, we can interpret about occupation, then education, and housing status, and other. There are like so many charts. I didn't want to put it here because it's like more than 10, 15. So just to give a kind of a summary like how the results look like. And these are the four predictors which had highest contribution to the model. Now, machine learning model comparison. As I mentioned that I'll compare like two metrics. One is accuracy, another one is kappa. So if you see the accuracy, you'll see SLRM is a stepwise forward logistic regression model. Has the highest accuracy at the top, and the accuracy was near like 74%. And the kappa was also highest. It's near, like it's between 0.5 to 6. Now, if you see the deviation, because this is the average accuracy, this is the average kappa score, because as I mentioned, after the cross-validation, there are like multiple times it trains. So you see, although the accuracy was very high, but the deviation was bigger, wider. Then how we select which model? So there is no, I would say like a golden rule that you select one model is the best. There is no the best model. Always there will be some relative information that we have to pick, and also it depends what we are looking for. So here we are looking for arsenic awareness classification. So after SLRM, then we have random forest. So random forest, you can see the accuracy was very close to, not too much deviation, like nearly 73% or 74%, but the deviation was very small. Similarly, for kappa statistics, the deviation was very small. Here, the right-hand side, you see kappa is basically, we use like Cohen's kappa. And in 1973, Fliss and Cohen, they created a kind of a robustness chart where the kappa value, if it's less than 0.4, then it is poor, and greater than 0.4, below 0.75, then it's fair to good. In this case, you can call that random forest was fair to good. But further in 1977, the Landis and Koch, they made it more granular. So it's like more easier to kind of categorize like what is the robustness scale. So again, you can say like this is moderately robust. So at the beginning, I mentioned that developing a model on categorical data is very, very difficult. We are not dealing with continuous data where we can have like very high accurate, close to perfect model. So for example, I think most of the students where we have may understand, especially people from environmental science and biotechnology, you may have developed any kind of like standard curve, for example, like for arsenic. And we have like arsenic concentration at x-axis, and then y-axis we have absorbance when we are creating a standard curve for arsenic, say either using USVI, VIS, spectrophotometer, or AS, anyone. Then with the increase in concentration, the absorbance is increasing. So it's basically we are looking for a straight line. But in socioeconomic data, you may not be finding any linear association. So that's why it's very, very tricky. So we are looking for a model that can capture non-linear relationships. So you have yes, you have no. So it's an S curve, sigmoid curve. So you are trying to capture the relationship between the predictor and the response in this curve. It's not a straight line. So that's why it's very, very difficult. So based after kind of like comparing and all, and you will find a very detailed discussion about how we selected random forest the best model. So random forest and KSVM, so support vector machine I mentioned at the beginning, there are different kernels where you select the different types of kernel. So I selected like radial that captures a nonlinear relationship. So logistic regression is mostly it captures a linear relationship, but random forest and SVM can capture nonlinear relationship. So that's why it was found to be the most accurate as well as the robust model. We reached to the conclusion. So after doing all the analysis like descriptive statistics and the machine learning, then the outcome that we can conclude is we already discussed, right? 64% people are arsenic awareness. Among socioeconomic predictors of arsenic awareness, we found that caste, education, and occupation had highest contribution to the models. In addition to that, safe water and sanitation behaviors also bring greater arsenic awareness among the community. In this study, there were like several predictors introduced for the first time, and one was definitely caste was one of them. But after that, trust and social capital. So social capital and trust, it came out another important predictors where people have trust in local communities and institutions. They have higher arsenic awareness. So that was one of the important conclusions that came out after the study. And as I mentioned, like support vector machine and random forest produced robust arsenic awareness models, and modeling arsenic awareness is a non-linear classification problem. So in the future, if somebody is advancing this study, either me or any other scientist, they should be actually looking for nonlinear classifier, not linear classifier, because one of the most important outcomes of this study is that this kind of a problem can be better deal with non-linear classifiers. So what recommendations we could actually make? So the more people are more aware, they are more inclined to follow good sanitation, hygiene, and health behaviors. So as I mentioned at the beginning, like risk perception is very critical. People, they don't perceive risk. They are not aware about coronavirus. That's why they are not following most of the rules. I should not say imposed by the government, but yes, any directions either by doctors or like governments or any scientists, unless and until we are aware of it and we perceive there is a risk, we don't follow. So arsenic, 64% people should be targeted for arsenic mitigation because they are more likely to adopt arsenic mitigation technology. That's why, since they are more likely to adopt, there is a high likely of sustainability of arsenic mitigation programs. Arsenic awareness and good safe water and sanitation behaviors also found a very contributing factor. So it should be promoted through education. As I mentioned about the local institutions, so local institutions and NGOs should be involved in arsenic awareness and mitigation programs because people, they trust them. Nonlinear classification, we have already talked about. There is another way we can handle this. It's a hybrid machine learning model. So basically, using one classifiers and combining with the other one, and so say I want to have one classifier that can actually capture all the nonlinear association between the data. And then I can use another classifier that can robustly predict model. So maybe that would be another option. The last point I would like to highlight here that, like surveying is very resource intensive. And I literally had to borrow, I received some scholarship for my travel, but in order to do the survey, I literally had to spend my own money. So in order to collect like socioeconomic and environmental data, definitely you need to spend a lot of money. But if you are doing, try to capture more data and then see if larger sample data could help like improve the performance of any machine learning model. So with this, my case study is done, and I have just request, and then ma'am can like me. I have two important sections, which is one is career opportunities, and the other one is collaboration. So I'm okay if we have question and answer now, or we can do question and answer once I'm done with career opportunities in the other section. Ma'am.
I think we can have the active session at the end. You finish with your lecture, and then we'll have the interactive session.
Okay, ma'am. Sure. Thank you. So, very interesting topic is coming up. So, as I mentioned, people's perception is very, very important. Globally, people have this perception that mostly, and students from computer science don't get offended or don't feel bad. But this is a global perception that artificial intelligence, data science, machine learning is for people who have background in computer science. But that's not the case. That's what we will talk about it. People from any background can do artificial intelligence. How? I'm not bragging it. I'll prove it right now. So artificial intelligence and environmental sustainability is Scop. So in 2018, the World Economic Forum, they published a report that where artificial intelligence can be used for environmental sustainability research or like any other studies. So they identified 6 major areas: biodiversity and conservation, water security, weather and disaster resilience, clean air, ocean, health, ocean, and then climate change. And there are like you can see, right? There are sub areas. I mean, you don't have to stick with the areas. You can have your own topic within the bigger category. So some of the examples here. So the presentation we just did is based on this publication that I did in 2018, and it was published in Journal of Environmental Management. Later, I started collaborating with various scientists across the world, and then if you see, we developed one hybrid model for groundwater potential mapping. And we all know in Bihar, we have this problem, right? In summer, water goes down and there are like water scarcity. I mean, recently I didn't study much, but I know like we have not only the water quality problem, definitely we have water scarcity problem as well. So we can also apply machine learning for groundwater mapping. Another work that I have been doing with them is one of the biggest natural hazards, which is landslides. Like in India, most of the hilly areas like Uttarakhand, we have this problem. So this one, what we did, like we kind of like marry like GIS and machine learning together, and then we developed prediction model for landslide susceptibility. Similarly, in Iran, we did the same work, developing a hybrid model. In Vietnam, we did the same work, applying different artificial intelligence methods. So artificial intelligence, machine learning is not restricted to only few domains. Yes, we can apply, and this is very, very useful. And I think these days, this is like picking actually attracting a lot of like scientists and researchers. So since I am from environmental science background, I joined an IT company where people are like 99.99% people are from computer science background. The first question used to be, Sushant, how come you are in this industry? You don't even have a computer degree. Then I used to take like 5 minutes and then explain, but they were right? I mean, that was the perception. What made me do this work? That's the training. So here, especially, and I will request all the students to listen carefully. I'm very thankful to AN College, the PG Department of Environmental Science at this moment, because you know environmental science is a multidisciplinary subject. We used to have all kinds of topics. At that point of time, we may understand, we may not, but that helped me a lot. How? Connecting the dots. So you have environment, then how the chemistry is related, how physics is related. I mean, arsenic research is primarily based on thermodynamics in most area wherever people are developing geochemical models or hydrogeological model. They are using thermodynamics like everywhere. So how the physics is connected, how geography is connected, geology, then you have statistics, you have social science, behavioral science, then you have GIS, remote sensing. What we need to do is to connect the dots. How it's, and that's the science. It helped me to succeed in data science because that helped me to create meaningful models, not just the models. And that motivated me to write an article where how my other fellows, like who did their masters or they are pursuing their PhD, if they don't find jobs in academia, in research or in NGO or in consultancy, how they can come into this world. So long story short, I submitted that article to this journal, and this is one of the topmost journals in the world, so ranked 3, Frontiers in Ecology and the Environment, and ranked 3 in ecology as well as in environmental sciences. And the editor, Dr. Silvers, she appreciated this article a lot. And I was very happy when then sent me the acknowledgement that that article became the top downloaded paper in 2019 in the world. So people from environmental science, biotechnology, or any other science, don't worry about it. You can do artificial intelligence. Now, that was, I was like holding for a long time to discuss with you guys. Now at the end, I would like to briefly talk about how I can contribute, how I can again go back to my academic family and I can do something that I always wanted to do. So, and I have discussed this briefly with Dr. Ganwar ma'am. Today, I'm presenting here in front of all of you. So I am planning to start an arsenic research scholarship. It will be a full scholarship to one master student who has interest in pursuing research in arsenic related issues. So every year there will be one scholarship and it will cover all the cost of that student. That's one that I'm proposing today. The second one, I'm planning to establish an arsenic library, like a digital as well as a regular arsenic library, in PG Department of Environmental Science, where you will have all possible books, journals, and other publications, like digital form as well as like the hard copy. And finally, I'm very much active in publications and collaborating. So definitely research collaboration with faculty members, students, the PhD scholars, postdoc scholars for publications, projects, internships for sure. And I'll be very, very happy to join any master's or PhD students' journey for their thesis. So with this, I'll stop myself. And again, I'm very much thankful to all of you. I feel blessed, definitely, and I had the opportunity to present this work in front of Bush sir, with whom I worked, and I learned a lot. Nupur ma'am, and many professors, Arun sir, like I never had any opportunity to work with him. But whenever I used to see him, like I always get like positive vibe. So I always remember him. Seema ma'am and many professors I know. So I'm really thankful to all of you, and thank you very much for this opportunity.
Thank you so much, Dr. Sushant. Your lecture was very informative, and more than informative, it was very, very useful. And the students who are present here, I think you are a source of inspiration for them. So if they want to pursue research in this field or related field, they can do so, and more so